In this video, we're going to explore the relationship between vertical asymptotes and limits. So first, a quick review. What is a vertical asymptote? It's when the values of your function go off towards an infinity. So there's kind of two options. They can kind of split and go off into two separate infinities. This happens a lot when you have something like 1 over x, in this case 1 over x minus a. Or they can go on the same direction. And this just happens when it's squared or to an even power on the bottom. So sometimes it jumps if there's just an odd power. It'll stay on the same side if there's an even power. As seen before, the limit will not exist at an asymptote. There's no single y value that our function is getting close to. However, we can still use notation to help explain what's happening at that x value. We just want as much information as possible. All right, so let's evaluate the following limit. So limit as x approaches 3 from the left of f(x). So again, we're looking at the left-hand side of 3. 3's here. And we're just focused on the left-hand side. All right, so as I'm getting closer and closer to 3, as I'm traveling along this graph, you can see my line just keeps going down, down, down forever as I get close to 3. So I'm going to say my limit is negative infinity. And even though I'm saying it's equal to something, this limit does not exist. It's not equal to a number. But notationally, I can write it's equal to negative infinity because it explains to the reader that as my graph gets close to 3 from the left, my y values are going to the negative infinity. They're getting bigger and bigger and bigger forever. What about 3 from the right? Well, I'm just going to do the same thing, except for on the right-hand side of 3. But you can see the same thing happens. This tail of this graph as I get close to 3 goes down, down, down forever. So my limit is going to be negative infinity. And we saw in our discussion about one-sided limits, if the one-sided limits agree, then our full limit's going to agree. And you can see that makes sense just at 3. If I go straight down, everything's going down to negative infinity. That's going to be my full limit. Still doesn't exist, but notationally, I can write negative infinity. All right, in this example, we're going to do the same thing. We're looking at the limit as x approaches -2 from the left. So we're still going to start off with our x value, -2. But we're just looking on the left of this. So just kind of in this region here. In that region, we can see as we travel along our function, we get close to that closed dot, and that's at 3. So here on the left-hand side, my y value is just close to 3. On the right-hand side of -2, right, in this green box, you can see my function just keeps going up, up, up forever. So in that case, my limit is going to be infinity. Because as my function or my values get close to -2 on the right-hand side, my y values just keep getting bigger forever. And what is our full limit at -2 going to be? Well, instantly you know if these two things are not the same, you just write this does not exist. All right, the limit on the right also doesn't exist, but we can actually write notationally that it's infinity. All right, but this one, there's no notation we could possibly write to make sense of this kind of weirdness happening at -2, so we just say the limit d and e, it does not exist. All right, so now we can define a vertical asymptote based on limits. And this is really the formal definition of a vertical asymptote, is that if any of these things are true, then you have a vertical asymptote. If any of your limits, as you get close to the x value a, go to any type of infinity, then you have a vertical asymptote. And the vertical asymptote, because it's this straight up and down line, it's the line x equals a. So if any one-sided limit or any full limit is equal to infinity, you have a vertical asymptote. All right, so write an infinite limit expression for the following graph. All right, try to do this on your own. All right, write as many as you can, and I'll kind of show you the answers that I come up with in a second. So I'll show you the answers in 3, 2, 1. All right, and here's two of the things you could have written. All right, the limit as x approaches -2 is infinity. All right, I'm at -2, and these values are going all the way up. And same thing at 5. These two also imply the other 4 you could have written. You could have written -2 from the left goes to infinity. You could have written -2 from the right goes to infinity. 5 from the left, 5 from the right. All right, but because the two sides agree, the full limits also exist. So the simplest way to write it would just be the two full limits. All right, but there's basically 6 different limit expressions you could write for this function. All right, so here's the important lessons from this lesson. All right, so vertical asymptote, when x gets close to a number, so x is getting close to a, but my y values are going to infinity. And again, it's kind of important to remember the limit does not exist. It's not equal to a number. We're just writing notation with the infinity to explain what's happening, the behavior of the function. All right, so this is a vertical asymptote and limits.